Hello everyone. Today I'm going to be filming a short video on how to do data exploratory analysis as a data scientist or AI ML engineer. So usually uh, data analysis is one of the first few steps for any project that you're going to embark on, understanding how to find any patterns that are within the data, as well as finding any correlation between multiple uh, variables. And so today I'm going to just be chunking my video as a univariate analysis and bivariate analysis. And so I think we'll try to use a practical example to help solidify any learnings. I wanted to film this short video because when I look on YouTube, there's not really um, very good explanations on how to do it. So I figured let me try to film one myself. Um, so let's start to get into it. So basically, this project was around think of like Uber Eats, but for New York. And so the problem set is how do we, uh, you know, make a better food delivery app? What data can we find? And so here we have a couple of the variables. We're going to import the necessary libraries such as NumPy, Pandas, PyPlot, Seaborn. So usually we start off by reading the data set and we just try to understand, like what are the variables, how many rows, how many columns. And so usually a good first step is to usually take a look at the shape. In this case, there's around like 1900 rows and 9 columns. And so again, we're just going to be trying to look at the data, see if there's anything missing. So we take a look at data types. Data types are another key thing. There can be ints, objects, floats, um, and also categorical variables, which is important. And it's good to know which variable is of what type. So that's why we use df.info. Continuing on, we try to look for any missing values. If there are missing values, generally speaking, we try to um, input a value like either NaN or perhaps a median value. Um, maybe I'll film a separate video on that, but there are multiple ways to help um, impute extra values if there's anything missing. So going on, um, we take a look at the statistical summary. So what type of information does this give us? So it gives us the mean, and we can take a look at the P25, P50, 75, and max. So we can see if there's any type of like skew in the data. In this case, uh, there seems to be a bit of a skew in some of the data points, and so it's good to keep in mind. Mhm. So, for example, if we look at preparation time, so we can see that usually the minimum is 20 minutes, the average is 27, but the max is 35. Um, it's good to take a look at that. Um, count value. Man, I have a bit of a cough today, but if we use count values, this gives us, it returns what are the different labels that are associated. So in this case, what are users rating the restaurants? So we could see that some people are giving 3 stars, 4 stars, 5 stars. but we see a large majority are not given. And so I think that would be useful data to any business analyst or um, anybody within the company. We should start trying to figure out why are so many of the orders not rated? How can we get more people to rate the food delivery process from, say, Uber or any food delivery app? So yeah, so now I'm scrolling down and we're gonna start the univariate analysis. So univariate analysis just translates to like taking a look at each individual variable on its own. What type of distribution does it have? So we can take a look at order ID, customer ID, restaurant name, cuisine type. So these four things that I'm plotting here are all from up above when we take a look at the data frame. And so that's where we're getting these labels from. And so after that, I plotted the cuisine types so we could see that this food delivery app offers a wide variety of cuisine. We can see Korean, Japanese, Mexican American, all the way down. We can see that a lot of consumers are having American food and Japanese food. Um, so those are the top two. As we keep going, so now it's the cost of the order. So here we're graphing it using Seaborn, and we can just take a look here. So it seems that the cost of the orders are hovering around $13, but it could go as high as 35, as low as around $5. And this is in histogram format, but it's also just saying roughly the same thing, just plotted differently. Days of the week. So we can see that days of the week, there's two unique values for days of the week. And then as we plot it in Seaborn, we can see that within this data set, there's weekend and weekday. Perhaps this is a good metric to know because maybe, let's say, there are more food orders during the weekend because people are relaxing at home versus the weekday. And so let's keep going. Ratings, we kind of went over this, but I think it gives us it more into a visual format. It's easier for a human to interpret that as an analyst. So one interesting thing that's within this data set is they don't have a rating of one or two. It's just three or higher or given. So as we go down, we see another uh, variable, in this case, food preparation time. So this one has a bit of a interesting distribution. Certain prep times are much higher, and the average, not average, but rather the median is around 27. So let's see here. Delivery time. This is also an interesting skew, but around more or less 50% of the time we'll have a delivery time of 25 minutes. So not too bad, but it seems I had done if we add up the P50 from the other one and add the P50 to this one, 27 plus 25 is 52 minutes. So I guess when you order, by the time you order, it takes time to prep it and then deliver it to your house. So that takes 52 minutes. From a data scientist or machine learning point of view, we could say, tell our stakeholders that, hey, maybe this is too long. Is there any ways we can reduce the total time? All right, so let's keep going. So we have restaurant names. So I think this data set had around 180 restaurants, and we can tell that certain restaurants are getting a high amount of volume and others are getting a low amount of volume. So here is just good to know what the top five are. see maybe what are they doing good, why are they the top uh, potential avenues for exploration. And here I'm filtering by weekend only. And yeah, like we said earlier, I guess American is the most popular on the weekend. Um, Percentage of orders costing more than $20. So here, as we were exploring, um, as we know, usually the way that these delivery apps work is they get a percentage off the total bill. And so I had wanted to explore how many orders are above $20, see how much um, the company could be making. And so it seems that of all the orders, around 30% are above $20, which seems good for the business, but I'm sure some product manager is going to want to bring that up. So, like, can we have more orders that are above $20? Like, they could look at that metric. Delivery time. We covered this earlier in the video. All right, so now let's go into the bivariate or multivariate analysis. So this is where we look at relationships between two or more variables to get an idea of any correlation. So there's positive correlation, where as one variable increases, it's likely that the other is going to increase. There's inverse correlation, right? One goes up and the other one will go down, or one goes down and the other goes up. Or there's a neutral correlation where it doesn't seem like the two variables are correlated. So let's take a look at what we had done in this exploration. So here we tested cuisine type compared to cost of order. So here this gives us a totally different chart, and we can kind of look at, oh, okay, there's a few outliers. Cost of the orders. Is there some that have a little more, how to say it? If we look at usually the P50 or the median, we can see that French has one of the highest medians in this data set. Mm. But it's not the most expensive. The most expensive is Mediterranean, it seems, with a few outliers that cost $35. Here we are doing cuisine type and food prep. So are certain cuisines taking longer to prep for? And let's see, looking at the P50s roughly, it seems that Thai food and Italian food are somewhat high on the prep time. Perhaps that's because Thai food has a lot of dishes that they have to make. Some are take longer and it pushes that median up. Italian as well. And so again, as if for anybody who's doing data analysis, uh, particularly bivariate analysis, um, there is a lot of data. If you're, let's say, using a data set of like 500, thankfully this was a much more manageable one where there was only like 9 columns, and so we could just compare and cross-reference and look at different stuff. So here we did day of the week and delivery time. So this actually gives us a very interesting data, which is that weekdays have a higher delivery time for this specific company. So this I had jotted it down that it's higher, and we should probably probe into like why is that? Is that because the weekends are higher, like the rather there's more traffic, and so the delivery time's higher? This is something worth looking into. And so group by restaurant. So this, I wanted to actually take a look at the restaurants and see which of them have usually the highest cost of order summated. And so if we recall, I believe the top five restaurants, like I'm pretty sure these were the top five restaurants. And so it's just good to see if we add up all the orders from Shake Shack, it seems that we get a total of 3,600-ish, which is actually surprisingly not a lot. But perhaps the data was in thousands. I'm not really sure. Um, Going forward, let's see. So ratings, delivery time. So yeah, so this one was interesting. I had observed that the lowest rating, which is a 3, has a very wide delivery time confidence interval. Um, Maybe that's making people pissed that if they're waiting $25, 25 minutes, it's more likely that they're going to give a lower rating versus, let's say, it's 10 minutes or, oh, actually, it's not even that much different. If it's around 24, people might not give it a rating, or sometimes they'll give it a 5. So this is interesting to see from a visualization point of view. Okay, so here we're getting into heat maps. So heat maps are a way of looking at the correlation, but in numerical values. So in this case, as we look and plot the data, we can see that there isn't really a high correlation. So in this case, they have 0.01, but a high correlation would be something like 0.5 or above, maybe 0.8, something like that. So it's good. So we don't have any highly correlated data, which is good. So if there was highly correlated data, then we would need to drop one of the variables, because it's basically giving repeat information. So let's keep rolling with the bivariate analysis. So I'm trying to think of whether I should just keep going, or the thing is, it's just basically like however many rows of data. Let me scroll all the way back up here. We can take like restaurant name. You can always do by like do restaurant name with cuisine type, restaurant name with cost of order, restaurant name with. So it can lead to a lot of analysis, but again, it could lead to some patterns. Um, so I'll just scroll all the way down. I believe I had to generate some business insights. And yeah, so actually, after we're done with the analysis, are there any conclusions that you can do to improve the business? So this is kind of important as, again, a data scientist or AI ML engineer. So let me just end off the video with stating the conclusions and recommendations that I had. So again, we are looking at this totally new data set, and we looked at all the patterns, and now at the very end, we've basically pulled out the key data that's of importance. So one, weekends on the food app were the most used, so it was most used on the weekends. Delivery times are shorter on the weekend. The company was making around 6K in revenue. I'm not sure if this was me misinterpreting, like perhaps the units was in millions or in thousands. I wasn't really sure. It wasn't given. But I guess it adds up to 6K of some kind. Around 70% of the orders costed less than $20. There's no missing data. 40% were not given a rating. So this, again, are all things that product managers can be looking at. They can be like, how can we boost the revenue? How do we make the delivery time shorter? Depends on what metrics that they are prioritizing at the time. The mean total time was around 52 minutes. So recommendations. In order to boost revenue, we can try increasing the total number of orders because again, we're getting a skim off the top of each bill. So if we can increase volume, we can get more revenue. Um, Boost the weekend sale. So we know that weekends are popular. It's the most used. So is there a way, can we drive some incentives to boost those weekend sales, given that they're more likely to spend on the weekend? Additionally, it says weekday delivery times were long. Yep. Is it worth trying to reduce that metric? That is worth looking into because we would be relying on like Saturday and Sunday to make up most of our revenue. Is there a way we can increase the amount of, days that we get more revenue? 30% costs more than $20. Yep. Is there a way we can encourage people to spend more than $20? This is a interesting, I guess, marketing type of thing where we can say, is there some type of incentive structure we could put? And lastly, can we devise a system that encourages more ratings? So I'm assuming this has a either desktop application or a mobile app. And so is there some sort of perhaps notification push that we could do that would encourage people to leave a review? Um, that's worth looking into. So I think that's around it. So this was kind of hopefully a shorter video that covered what one should do when we first get a data set, um, and perform all the necessary exploration via univariate analysis and bivariate analysis or multivariate analysis. Thank you very much. Uh, I will make more videos in the coming days and weeks. Thank you.